Welcome to Brain Vision.
So the problem is set in this format. We have three identical mass, 1, 2, and 3. Each has a mass of 8.5 kilograms, and they are hanged by three identical springs, K1, K2, and K3. The spring constant is 7.8 K Newton per meter for each of them. And for the springs, their original length is 12.0 centimeter, which is also identical. And we are asked to solve a two parts question. The first part asks us to draw the free body diagram for the three masses. And the second part asks us to solve for the length of each of the spring. So let's start the first part. If you look at the structure here, we notice the mass number 3 is attached to only one spring, so it's relatively simpler than the mass number 2 and mass number 1. So we start with mass number 3. So we have the mass here, and of course it has gravity coming downwards from the center, and it's also attached on top by a spring number 3. So it has the spring force going up like this. We call this spring force T3. So that's it for mass number 3. And now we look at mass number 2. Again, the easy part is the gravity. We have the gravity for mass number 2, but this time, aside from that, mass number 2 is attached by spring on both sides. So the side from below, we should have another tension or spring force, but this is exerted by spring number 3, so this force should be the same on both ends. So this again should be T3, and another force coming from up top, the spring number 2 attached on top of the mass number 2 and pointing upwards. So this is the T2. We call this T2 because it's the spring force for from the second spring. And that's it for mass number 2. 1 gravity and 2 spring force. 1 going down below, 1 going upwards. Same case for mass number 1. So we have the gravity first, and again it's attached by springs on both sides, and spring number 2 is holding it down, so it's pointing downwards, and it's the same as T2, and the other springs is holding it up, so it's pointing upwards, and it's from spring number 1, so this is T1. And that's it, all the free body diagram for 3 masses. And now let's solve for the second part, which asks for the length of each of the springs, which is equivalent to asking the length displacement of each of the springs, which, if you remember Hooke's law, is T equals to K times delta L. T is the spring force, K is the spring constant, delta L is the displacement of this certain spring. So asking for this delta L, the displacement, is actually equivalent as asking us to solve the spring force for each of the spring. That means solving for T3, T2, and T1. And after we get those, we can plug that in this Hooke's law equation. And since we know the spring constant K, we can easily get the displacement delta L. And we add on the displacement, its original length, we can get the new length of the spring one by one. So let's do that for the mass number 3 first. So we see here, as we have drawn earlier, the free body diagram for mass number 3. It is at rest, so this two force, T3 and G3, should balance each other. So we have this, T3 equals to G3. Which actually G3 is the gravity of the mass number 3 equals to m times G. I'm not using index for m because it's identical mass for all of them. And G is just 9.8 meter per second square. And if we recall, to get the spring displacement for spring number 3, which is hanging here, we have Hooke's law for the spring T3 is actually K times delta L3. And we plug this equation into this, and we divide both sides by K, and we can get delta L3 equals to m times G over K. And if you recall from here, m is 8.5 kilograms and K is 7.8 K Newton per meter, and we can get 8.5 kg times 9.8 meter per second square divided by 7.8 K Newton per meter. And this gives us approximately 1.07 centimeter. And this is the displacement of the spring number 3. Get a length, we need to add this on top of the original length, and we know the spring is stretched longer, so this must be positive. So then L3 should equals to L0 plus delta L3 equals to 12.0 centimeter, which is the original length, plus 1.07 centimeter, which is the displacement or the stretch, which give us 13.07 centimeter for spring number 3. Okay, so now we finished with mass number 3 and spring number 3. Let's take a look at spring number 2. So spring number 2, to solve the length of that basically means we need to solve for T2. And again, we look at the free body diagram of mass number 2, which is at rest. So all the forces should balance each other. So T2 should balance with G2 plus T3. And we know from here T3 is just the same as G3, which is mg. And G2, which is the gravity of mass number 2, is also mg. So we actually have T2 equals to n times g plus m times g, which is twice m times g. And again, we use the Hooke's law. T2 equals k times displacement of the second spring, which should be somewhere here, attaching mass number 2. And this plug in T2 equals 2 times mg in here, and divided both sides by k, we get delta L2 equals 2 times mg over k, which, if you look at the previous solution again, delta L3 is 1 times mg over k, which is 1.07 centimeter, and this is delta L2 is 2 times mg over k, which is just 1.07 times 2 centimeter, which gives us 2.14 centimeter. And again, to get the full length of the second spring, we add this spring stretch on top of the original length L0, and that gives us 12.0 centimeters plus 2.14 centimeter, and that will give us 14.14 centimeter. That's for spring number 2. So you can do the same thing for spring number 1. We just need to do a similar process to solve for T1. So we know the drill. T1 should be balance G1 plus T2, which, if you see there's a pattern here, T2 is 2 times mg, G1 again is mg, and so that is mg plus 2 times mg, and that is 3 times mg. And then we plug this into Hooke's law. T1 equals to k times delta L1, which will give us delta L1, the displacement of the first spring, equals to 3 times mg over k. And this will give us 3 times 1.07 centimeters. And that is 3.21 centimeter. And then we add this spring displacement of the first spring on top of the original length, and we can get the real length of the spring number 1 to be L0 plus delta L1 equals to 12.0 cm plus 3.21 cm, and in total that gives us 15.21 centimeter. And that's all of it.